We are going to graph two of these today. And so we're going to start with this first one. And the first thing we have to do is factor. So we're going to factor this, and we will get x minus 3 times x plus 1 over x plus 1 times x plus 2. All right, so will I have any point discontinuity in this one? Yes, I will. The x value for that is -1, so I will cross those out and get my new reduced function, which is x minus 3 over x plus 2. So then to find the y value of that whole, I substituted into my reduced function, so that'll be -1 minus 3 over -1 plus 2. So that would be -4. -4. Sorry, my brain was -4. I had a moment there. Okay. How many roots do I have? 1. So 3. How many vertical asymptotes do I have? 1. And, ooh, and it is not a set. It is at x equals -2. Do I have any tangency or togetherness? No, because I don't have any exponents anywhere, so there's none on that. Do I have a horizontal asymptote? Yes, because it's tied in degrees, so this would be y equals 1, which means I do not have a slant asymptote. My y-intercept is going to be at 0, -3/2. And then since I'm about to scroll, I'm going to rewrite this so I can see it once I scroll. This is x minus 3 over x plus 2. Okay. So on my number line, I have to put my asymptotes and the roots. So I'm going to have a -2, a +3. The 3 is a 0, so it's closed. This is an asymptote, so it's open, right? So then I'm going to check points. We will start with -3. So that would give me negative over negative. That's positive overall. Then I can put in 0, and that'll give me negative over positive. That's negative. I can put in 4. That'll be positive over positive. That's positive overall. Okay, so let's think about what this is telling me about this graph that we haven't even graphed yet. We know that there's an asymptote here, and there's a 0 here. That's a very crooked asymptote, but it's fine. And so if I'm positive the whole time here, now this isn't going to give me my exact graph, but it's going to give me an idea of what's happening here. If it stays positive the whole time and I have that asymptote, it has to look something like that. I don't have any togetherness, so I know that it can't start up here, right? And I didn't shade my graph either, but sorry. So I have positive, negative, positive. So I know it's going to be down here because it's negative, but also I didn't have any togetherness. So it's going to have to hug the asymptote over here. I'm going to have to change from negative to positive with the 0, so I'm going to cross through the axis, and then it stays positive, so it could look something like that. But without knowing other things, I don't know exactly, but that at least gives me the positive and negatives with it. Does that make sense to you? Okay, so let's, on our graph then, let's get some things on here. Let's get our asymptotes on here. So I have one at x equals -2. And then I have one at y equals 1. Okay. So then I'm going to plot the points that I know. I have a hole at -1, -4. Hole right there. I have a 0 at 3. And I have a y-intercept at 0, -3/2. Okay. So I feel like this part of the graph I've pretty much got down. Okay, but if you look at this part of the graph, starting at the asymptote going to the right here, starting at the asymptote, we know it was negative until we got to 3, and then it's positive. Well, the way I have this drawn, I have it drawn like a polynomial, like it's going to go like that. Is that what's actually going to happen here? My end behavior, as x approaches infinity, what does y approach? 1, because that's my asymptote, right? So it's still going to be positive, but I didn't have that horizontal asymptote up here, so it looks more like this. And because remember, this is just telling me that it's positive. It's not necessarily giving me the shape up there. That was just kind of an idea of what's happening, but it will stay positive. It's not going to cross back over. So this is going to look like, oh, that was really bad. Let me try again. Something like that. Now for this part over here, I know from negative infinity to negative 2, it's positive the whole time. So it'll be up here, but I need to get at least 1 point. So I usually start just with 1 on the other side of the asymptote. So we'll start with negative 3. Let's find f of negative 3. That would give me negative 3 minus 3 over negative 3 plus 2. This is going to be negative 6 over negative 1. That's 6. So I can go to negative 3, then 1, 2, 3, 4, 5, 6. Okay, so that doesn't really tell me how close it gets in here, because it could come close like this. It could swing out real far right here. So I think I'm going to need to do f of negative 4 as well. So that's going to give me negative 7 over negative 2. So that's a positive 3/2. So I can go to negative 4 and then, is that right? Why do I feel like that's not right? Oh, that's right. Negative 4. Oh, it's not 3/2. Oh, what am I doing? That's why I'm confused. 7/2 doesn't become 3/2. It's 7/2. It becomes 3.5. That's why I was doing stupid things. Okay, negative 4 and then 1, 2, 3.5. So again, it could come down real close here, or it could swing out farther. So I feel like I probably need another one. And I'm going to get negative 8 over negative 3. So that's 8/3, which is 2 2/3. So it's about right there. And then I think those 3 are probably good enough for me to get the idea of how the curve works. Okay. So there's no set rule for how many points you have to find. Sometimes you don't have to find any. Sometimes you find 1 and it's totally enough. We'll do another one where we find 1 and it makes everything clear. Sometimes you need to find a few so you know exactly where that curve is going. Okay? We good? What questions you got? Awesome. Let's look at number 2. All right, so I'm going to start off by, factoring. So I'm going to get negative 6 over, so it'll be x minus 3 times x plus 2. Will I have any point discontinuity? No. How many roots do I have? None. There's no variables in the numerator. How many vertical asymptotes do I have? 2. I have one at x equals 3, one at x equals negative 2. Any tangency or togetherness? Nope. Any horizontal asymptotes? Y equals 0, good, because it's bottom heavy. So that means there's none of these. My y-intercept is going to be at 0, what? 1. Okay, so then I'm going to scroll, and I'm going to rewrite that so I can see it. You don't necessarily have to rewrite yours. I just can't see mine. So f of x is equal to negative 6 over x minus 3x plus 2. So on my number line goes my roots, which I don't have any, and then my 2 asymptotes. Those are both open. So if I choose negative 3, now my numerator is negative no matter what. So I got a negative numerator, and then I would get negative and negative, so that's negative overall. 0, I would have a negative numerator and then negative positive. That's positive overall. 4, negative numerator, positive, positive, negative overall. So this is what my sign chart looks like. So let's think about kind of in general what that tells me about this function. Well, if it's negative the whole time from negative infinity to the asymptote, it's going to have to look something sort of like that. There is no togetherness, so it can't be down here, plus this says it's positive, but this is supposed to stay positive the whole time between these 2 asymptotes, and I don't have any roots, Okay, it's not going to bounce off the axis or anything like that. But I have to be positive and I have to end positive, so it's going to have to look something similar to that. Like that's my only option because I don't get to cross through the vertical asymptotes. I can cross a horizontal asymptote, but I can't make that negative because it's got to be positive the whole time. And then this one is going to have to be negative the whole time, something similar to that. Okay, so that kind of narrows down what everything's going to look like on there. So let's go ahead and get our asymptotes on there. Our asymptotes are at x equals -2. Then we have one at x equals 3. And then our horizontal asymptote was at y equals 0. And so those are my asymptotes. Then I've got to get the points on here. I don't have any roots. I don't have any holes. All I have is a y-intercept at 0, 1. That's not a whole lot to go on, right? I mean, I know that from -∞ to -2, it's going to be down here, but I have to choose at least 1 point. So let's go ahead and try -3. So f of -3 will give me -6 over -6 times -1. So that is -1. So -3, -1. Do you feel like in that section we need any more points? I think that's pretty good. I mean, it shows you how far it goes. So that's really all the one that we need. It's going to look like that. All right. So in between these two asymptotes, I have this 1 point. It is possible to cross a horizontal asymptote, but I can't cross this one because that would make it negative, and that's not okay. So I'm going to find one other point. We'll do f of 1. Let's see what happens here. I'm going to get -6 over -2 times 3. So that's going to give me 1. Okay. So what's in between these two is not a parabola, but it looks like a parabola. It has the same kind of shape. Where do you think the relative minimum would be in general? About 1/2 probably. I mean, we don't know if it's exactly symmetric, but it has to be between these two, right? Because if I'm here and then I'm here again, it's not going to box off. It has to be curvy, so it's going to have to drop down a little bit and then come back up, right? So if you wanted to find -1 and 2, I mean, we could, but we have the general shape, and so we know it's going to come down. It's going to dip below those a little bit. It may not even look like you really are when you do that just because they're so close together, but it's going to have to look something like that. And then on the other side of that asymptote, it's going to look something like this. So I'm going to choose one on that side of the asymptote, which would be at 4. So f of 4 would give me -6 over 1 times 6. That's -1. I go to 4, -1. Do you feel like we need any other points in that section? Nope, I think that one's probably enough. It's going to look like this. Okay. What questions you got? On delta math, you're not going to be choosing any extra points. On delta math, once you get the asymptotes and the intercepts and the holes in there, that's all you really can graph at this point, and then it graphs the rest for you. But tomorrow, when I give you a piece of paper, you're going to have to do that because it's not going to just show up for you, okay? What questions you got? We all good? All right.